Rather than passing each pixel to the input layer, we pass the pooled feature map to the input layer, which is much smaller in size and focusing on specific features. Now let's understand CNN architecture. A CNN typically has several types of layers working together. The first one, the convolutional layer, which applies filters to extract features. Filters are also called kernels or feature detectors, and it produces the feature map. Before we go into feature detectors, let's understand about human vision analogy. Okay, think about how humans recognize things. So our brain does not process the entire image at once. It identifies small parts like eyes, mouth, or legs first. Then it combines these smaller patterns to recognize the whole object. So if I show you this image, what would be your first guess? You might say it's a frog or toad, right? Even though you cannot see the complete picture, you can recognize it by eyes, the pattern of eyes and mouth. Similarly, if I show you this image, right, it's a half picture, but still you will be able to recognize, you can see the legs, eyes, some part of mouth and some part of body, right? Similarly, if I show you just the legs, still you will be able to make some guess that it's a frog. Now these small parts or patterns are called features. And in first layer, we'll detect these features. That's why it's called feature detectors. Okay. Okay, so this is the same image of a frog, and these are our features: eyes, right? Feet, legs, mouth, eyes, mouth, and back. So these are called features, and we'll detect these features. Okay. Okay, before we understand how feature detectors work in complex images, let's simplify the problem. In this example, we had a small binary image, just zeros and ones. You can think of ones as white pixel and zero as black pixels. Now CNN learn to detect meaningful shapes or patterns from such simple pixel grids using something called filters or kernels that scan across the image. Okay, what are those patterns? So this is one pattern, the loopy pattern. Okay, this is one pattern, a vertical straight line. This is one pattern, the horizontal straight line. This is one pattern, a diagonal. Okay, here we have two patterns, two loopy patterns. Okay, now you may be thinking, what is the need of this feature detection? So instead of connecting every single pixel to every neuron, like in artificial neural network, ANN, CNNs focus only on small regions of image at a time. These small regions are analyzed using filters. This makes CNN far more efficient and much better at recognizing patterns in large images. Okay, so for example, rather than passing each pixel to the input layer, we pass the pooled feature map to the input layer, which is much smaller in size and focusing on specific features of the image. Okay, here is our first convolution example. So on the left, we have a simple 7 cross 5 binary image. So these are 7 pixels and these are 5 pixels. Okay, this is our feature detector. This is 3 cross 3 filter. And when we apply this feature detector on the image, we'll get the feature map. Okay, so let's understand this. Now, how we will apply this feature detector or filter on this image. Okay, so just think of it, placing this feature detector on top left region of the image. Okay, so like this. Okay, then we multiply each pixel with the filter value. So 0 cross minus 1, 1 cross 1, 1 cross 1, and so on. Then we sum them up. So, okay, so this is the multiplication. So 0 cross 1, 1 cross 1, 1 cross 1 that we have seen. Then the second row, 0 cross 1, 1 cross minus 10, and then 0 cross 1, and so on. And then we sum them up. So we get minus 7. And we get our first feature map value, minus 7. Now this means the pattern detected by the filter does not match with the part of the image. A negative value usually means a weak or opposite correlation. Okay, so what we are detecting here, the loop, and here we did not find any loop. So that's why we have negative value, right? Now we slide the same filter to the next region of the image and we'll get another value. Okay, now the filter is moved to the right. Now we'll repeat the same process. So this is 1 cross 1 plus 1 cross 1 plus 1 cross 1. And same way these two. So total 1, 2, 3, 4, 5. And these are 0. So this will be 0. So total 5. So if you notice, earlier we had -7. Now we have 5. That means this region of the image matches the filter pattern better than before. So we can see one arc here, okay? And we are detecting a loop. And we got one arc, so we got positive value +5. Now by repeating this sliding process across the entire image, we will generate the matrix of numbers that is our feature map. So let's do that. Now we will move further. You can see that filter is moving one step at a time. Every time it moves, it performs the same multiplication and summation process. So on this window, the value is 2. Now this is our first row, -7, 5, and 2. This shows that some part of image match the pattern very strongly, while others do not. This is how CNN begins to see the structure inside the image. Okay, so now we cannot go further towards the right. So we'll go downwards, okay? And repeat the same process. So we get -7, we get 5, 2, -7, -5, -8, -6, and 8, okay? So we have got the value as 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. That means we have found the loop, okay? Now let's go further. So -6, -8, -6, and -8. Now we have scanned the entire image using this 3 cross 3 filter, and this is our final feature map. Now this feature map may look like just numbers, but it actually represents detected features. Positive area shows a strong match, maybe edges or corners. Negative ones show weak or opposite patterns. So we just saw that for number 6, the loop-like pattern was detected somewhere here in the feature map. Okay. Now let's say if the number is 9, then we'll find the pattern somewhere towards the top of the feature map. Okay. And now let's say if the number is 88, right? Then we will find multiple loop patterns in our feature map. Okay. Now let's come back to number 6. So far we have detected this loop-like pattern. Next, we need to detect this vertical pattern, right? Or horizontal slash diagonal pattern. So we will have multiple feature detectors or filters. Okay, so just now we have seen one for this loop pattern. We'll have one more for this vertical and one more for this horizontal slash diagonal. Okay, so this is for the horizontal slash diagonal, right? So the feature map will look something like this. Okay, next the vertical pattern, right? The vertical pattern, and the feature map will be something like this, the vertical pattern. Okay, and the next is loop pattern, which we have already seen. And this is the feature map. Okay. So now let's clear the screen. Now, if we combine all the feature detectors, right, for the horizontal, for the vertical, and for the loop, we'll have feature map that will look something like this, right? Now that we understand how each CNN component works, let's see what happens when we pass the actual image. Okay, so this feature detector will detect the eyes, we'll apply the activation function, and we'll get the feature map. Okay. Okay. Another feature detector for mouth in the same process. So this one is for the legs and this one is for the feet. So here is our original frog image. This is the raw input full of pixel values and color details. Now let's run the convolution filters. Here is the results. These are the feature maps. These are 8 feature maps because we have selected 8 channels. Okay. If you notice, each map looks different because each filter focuses on a specific kind of detail. One might highlight the frog's outline, another might emphasize its texture, and another might catch the boundary between frog and the background. Now with this, we have completed the first layer, that is convolution layer, where we applied filters and we got the feature map.